Good morning.
Good evening, sir.
Oh my Lord, I apologize. The body know when it is tired here, guys. The body knows when it is tired, and the body takes on sleep when it is tired. It tells you that you're tired, and it causes your eyes to close and you drop asleep. Oh man, I apologize.
Good evening.
Good evening, my love. How you do? Shamara,
Not
my
too,
brethren. Sorry, say it again, Utterly.
not too bad. I thought I missed something, but it looked like I
Oh
missed
no,
it.
you don't miss a thing.
Okay.
You don't miss a thing. Shamar, my virgin, big up yourself.
Sir.
Oh, where were we again the last time?
So the Newton-Raphson method.
The Newton-Raphson method, yes. The method that I'm going through that I think you guys not catching. So I clearly did a bad thing in trying to introduce a topic to you. So we're going to go again. By the way, let me ask a question. Anybody understand what the Newton-Raphson is, how to do the calculation based on what we did the last time? Or it's still fuzzy?
Sure, it's getting there.
Kinda, sir.
It's getting there. Just need some more practice, but I have the basic understanding.
All right. Good to know. Is there anybody in the class that don't have a clue what I was doing the other day? You must talk to me, talk to me now.
Yes, sir. I think I understand. No.
Okay. All right. Just a point of information. Pink flag going around here. So be careful of what you look on or at or who you look at. It's going around. It's going around. All right. I'm trying to bring up my document. You know, I need to maybe put this in chapters in a second. Find. But this has 158 pages. This is like a text. All right. Let me give another attempt, and hopefully this one will look a little better, feel a little better. Um,
Sure, let's start one example, but I didn't think when it's supposed to complete it.
yeah,
Mhm.
thanks for that. But I'm going to, oh my Lord, I'm going to see if I can, I'm going to see if I can project this diagram again and make another attempt so that you guys can see what is happening. All aboard, do I have your undivided? Can we go? No? Hello, somebody?
Yes, sir. You can start. Mhm.
All right, so I have my curve as is defined by a function. The function could be anything. It could be cubic, it could be quartic. I have a function drawn on my Cartesian plane. I want to guesstimate the solution of this function, but I don't want to go and do the actual solving of this function. So what I'm going to do is to look at some iterations. I'm going to look at several iterations so that I can inch closer and closer and closer and closer to my solution. How are you going to do that, sir? Thanks for asking. I am going to be making an initial guess. I'm making an initial guess. Why did you start it there? I have absolutely no clue. It's just a guess. Starting somewhere. And I'll see where I end up. Starting somewhere, and I'll see where I'll end up. So what I'm doing here, I'm drawing a tangent at this point. Here goes my tangent. A tangent to a curve is that line that touches a curve exactly at a single point. So at my initial guess, I am drawing a tangent. I am drawing this tangent in such a way, watch me, that touches the x-axis. And why, sir, did you draw that tangent to touch the x-axis? Because what I'm trying to do is to, I'm in search of the solution to my problem. I'm in search of the solution to my problem. You know, sometimes we're having boyfriend and girlfriend issue, or man and woman issue, husband and wife issue, or it could be a very good friend that you really check for and something tick off and we're not having a disagreement. And then you go to somebody, see to yourself, you go to somebody and you bounce off the information off somebody. Watch me. You bounce off to somebody and you touch back the problem. Because remember, my curve is my problem now because I'm trying to find a solution for my curve. You bounce off the problem to somebody and you talk to the person, you recognize the boy, the person tell you what you want to hear. And I'm drawing another tangent at this point. This is going to be my second iteration. And I draw that tangent at that point, and I catch somebody else who is willing to listen. And this person, no, tell me what you want to hear. So, bounced off again. I catch back the problem. And again, I'm drawing another tangent to the curve. I draw another tangent to the curve and I catch somewhere. But right at this point in time now, me can say, may I get closer to the exact root? I'm going to say, you know what? I'm a brethren. And incidentally, many times over, it is your closest friends, or supposedly your closest friends, that cause you the greatest pain. You say you are the plan. I'm a brethren. I'm a check for my brethren, my God. I'm gonna forgive my brethren. At this point in time, you're not gonna bounce off nothing on nobody again. Cause you bounced off enough on somebody and you say, boy, yo, my brethren, me check for my brethren, I go forgive my brethren and call up my brethren and say, yo, we need to look for 1 minute. So I moved from a point where I was so far from my solution and I keep drawing these tangents. Now, if you look clearly at my drawing, you will see f dash of x1, f dash of x2, f dash of x3, so forth and so on. This f dash are my derivatives. They are my derivatives, and which is why when we look at the formulation for Newton-Raphson, it says xn minus f of xn all over f dash of xn. So right there and then, I have f of x1 over f dash of x1, f of x2 over f dash of x2. Let me go again. You have x1 minus f of x1 over f dash of x1. We have x2 minus f of x2 over f dash of x2, x3 minus f of x3 over f dash of x3, so forth and so on. And you can go up as many times as is necessary until you get to a point where the answer for one something is equal to the answer for another something. And no matter how many times you do it thereafter, you can get the same answer because you have reached your solution. It make it any clearer now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Right, good. So we were at a question. What question was it, Ottilie? Was it the first question? Was it this
Example 2. We
example?
did that one already. Yeah, we reached at the, I think it's second I. We did the first iteration. Let me see. Yeah, we were supposed to try it where the rest of it.
Okay,
the
good job.
Mm.
All right. So thanks, my love. So in this here case, we are given an equation. It says we're given an equation. An equation, x cubed is equal to 2x, 2 minus 2x. And it says I'm supposed to show that the equation has a root that lies within the interval 0, 1. It means, say, the root of the function is going to be 0 point something something, but it now going to reach 1. So my answer lies between 0 and 1. It says, hence, find the root to 2 decimal places. Now, from the question says, to do the something to 2 decimal places, it means, say, I have to go work in more than 2 decimal places and then round off. What is customary for me when it says work into 2 decimal places, I normally work into 2 more. I work into 4 decimal places. So when I'm rounding off my answer, now my answer will be round off very close, if not exact to what the teacher says. Can't go wrong. But there's no way they can say work in 2 decimal places. Are you working in 2 throughout the question? Your answer is going to be off. You have to work in at least 3, preferably 4. All right, you don't have to go to 5. All right. So what I did here, I think I would have first transposed my equation into a manner where I can get it and set it equal to 0. So I would have said x cubed plus 2x minus 2 is equal to 0. And I know my limit is going to be between 0 and 1. So therefore, if my function has a root between 0 and 1, I'm going to add the lower bound, which is 0, I'm going to add the upper bound, which is 1, and then I'm going to divide that by 2. I'm technically finding the midpoint. I'm technically finding the midpoint. All right? I'm technically finding the midpoint. And when I add 1 to 0, I'm going to get 1. And when I divide it by 2, I'm going to get 0.5. So therefore, my first iteration is 0.5. That's my starting point. Then, sir, you couldn't just start at 0. No. If they say to you that the root lies between 0 and 1, you're required to find the midpoint. And you're going to start at the midpoint. Sir, why? Because if you do that, chances are you're in a need 6 or 7 iterations for you to come down with the answer. And then the question may say to you, use 0.5 as a first iteration, and then complete the question by doing 2 more iterations, or sometimes the question says 3 more iterations. Now, when you do 2 more or 3 more iterations, it's still far away from the answer, because you did not start at where you're supposed to start, and you will get the question wrong, because you'd have been too far away from the solution. So the instructions must be adhered to. So I am going to be needing several bits of information. I'm going to be needing my original function, x cubed plus 2x minus 2. And I'm also going to be needing the derivative of that function. And when I differentiate that function, I'm going to get 3x squared plus 2. I have everything that I need, because my second iteration is going to be equal to my first iteration minus f of my first iteration divided by f dash of my first iteration. My first iteration, x1, is equal to 0.5. Since it falls in the interval, 0 plus 1 is 1, divided by 2, 0.5. My second iteration, x2, is going to be given by the first iteration minus f of the first iteration all over f dash of the first iteration. See here, so anyway, I say x1, I'm going to substitute 0.5. So f of 0.5 is going to be 0.5 cubed plus 2 times 0.5 minus 2. And that's going to be up in here. The result is going to be up in here. And then the result of f dash of 0.5, which is 3 times 0.5 squared plus 2. See here? This is what it is. And then I'm going to evaluate it. F of 0.5 is going to be 0.5 cubed plus 2 times 0.5 minus 2, and I get negative 0.875. And f dash of 0.5 is going to give me 2.75. And when I substitute it in here, I'm going to get 0.8181. And I think we had done the second iteration, because I remember 0.8181. Agree with me?
Agree, sir.
Yes, sir.
And then now, I'm going to ask you to do the third iteration for me now. The third iteration is simply finding the second iteration minus f of the second iteration all over f dash of the second iteration. Anybody seen the significance here? I have to calculate the previous iteration in order to calculate the next iteration. Talk truth.
True, sir.
Yeah, man.
Yes,
So I
sir.
can't just jump into it and say, yo, I'm going to find the fifth iteration when it is that I don't have the fourth. And I can't calculate the fourth without the third. And I can't calculate the third without the second, and the second without the first. All right? So I have to do it in succession. In succession. So do me a favor. I want you to evaluate for me now. The third iteration. I want you to evaluate the third iteration for me. The second iteration is 0.8181. All right? So you can substitute that into your f of x over your f dash of x. Evaluate that, get your answer, put it down. I'll check it in 2 minutes. Start from it, please. Obviously.
Zoned
Part-
out, sir.
Get in
Oh.
there, sir, get in there.
Okay, cool. Part of what I'm doing, just listen to what I'm saying here, and then I'm mute again. Part of what I'm doing here is an exercise to get you to see if you know how to use your calculators. Or I'm taking a deliberate effort to teach you how to use your calculators. All right, like I did with the exponential function for the trapezoidal, I'm doing here. You have to know how to use your calculators to get this stuff. I'll give you another minute and then come back to you.
Finish, sir.
Thank you, sir. What about the rest of you?
Sir,
Maintenance.
may I work
Finish
it
as well,
up?
sir.
The first one, the second one over. When I work it, put everything in the calculator all at once, me get a different answer from when my work out. The work it out and then add it together.
Okay. Simon, you're saying you finish?
Yes, sir. I said I got an answer.
You got an answer. Good job. Um, um, all right, all right, all right, all right. Uh-oh. Okay. I've got a suggestion already for the answer. What did you get for the third iteration?
0 points, yeah. There we go. The next thing.
What did you get? All me ears say yes,
Sir, I
0.
got that, yeah.
Oh, you got the 0.7723?
Yes, sir. 0.7723, yes, sir. They can
Do you
work
know,
it
do you
then.
know what I want you,
Same, sir.
no. Aston is not here yet? No. Um, what about the rest of you? Chevy? Oliver?
Yes,
Sir,
sir.
got
Sir.
Okay. So, uh, anybody got the fourth iteration?
yes, sir.
Working it, sir.
All right. Continue working. So you're okay with this, right, Taj? With the third iteration, right?
Yes, sir. Mhm.
Very nice. Proud of you. Where is your sound
Uh,
alike?
he was here, but I'm not seeing him anymore. So I'll reach out to him, sir.
Please and thanks.
All right.
Sham, where you stay?
Good, sir. Working the fourth iteration
Fourth
now.
iteration. Very nice. Oliver? Uncle Mark? Did it? Dina, you okay? Got one answer ready. I need to get more answers, please.
Sir Michael said he just reached home, so he'll be on soon.
Thanks, Pops. Wait, what does that mean? I have two answers. I have three answers. Talk to me, guys. I need to hear the others. Still working?
Finish, sir.
What is the answer?
For the fourth iteration, 0.7709.
All right, so you got the same answer as two of three students. One of the students' calculation was slightly off at 0.69. Can I stop right there?
Yes, sir.
Why?
So because when you do the fifth iteration, you get about the same answer.
Why?
Because we reached the end of the iteration.
You're right. You found the root of the equation.
Okay.
Right,
All right.
right. So when you find the root of the equation, it doesn't matter how many more iterations you would have done, you're going to end up with the same answer. All right. So the fifth iteration, I will ask you to do it because I end up with the 7709. You notice here, for the third iteration, I would have been at 7723. But the question did say to you to 2 decimal places. So to 2 decimal places, that is 0.77. The fourth iteration is 7709. To 2 decimal places, it is 0.77. So I would have reached my endpoint between iterations 3 and 4. But for teaching purposes, I went and did the fifth iteration. And look at what happens with the fifth iteration. 0.7709 and 0.7709. I get my values right down to the T. All right. So it says, because the values are so close, there's no need for us to do another iteration. We would have gotten our answer at 0.77. Fair enough?
Yes, sir.
All right, there goes
Yes,
another
sir.
question. Go ahead, please.
So in the exam, what you must work with in the exam? 2 decimal places.
It depends on what the question asks you.
So we'll stop at the third iteration.
Let us look at this question. It says, show that the equation such and such has a root alpha between 1 and 3. It says to use Newton-Raphson method, correct now to 3 decimal places to find the next 3 approximations, taking 2 as a first approximation, x1. Can you see how they got 2 as a first approximation? Anybody, somebody?
Is that the
Okay.
first and second?
Yes,
No,
sir.
Oh, because it's between 1 and 3.
because it's 1 and 3. So they add 1 to 3 to give you 4, and 4 divided by 2, you find the midpoint of 4, which is 2, right? So 2 is going to be the first iteration. So it says we're supposed to do the calculation to 3 decimal places to find the next 3 approximations. Now listen to what the question says. To find the next 3 approximations, taking 2 as a first approximation. So how many more approximations are you going to do?
2 more, sir.
Okay, run it. Quick and fast. before we see, all right?
Yes, sir.
Cool.
Finish, sir. Sir, finish.
You're muting us, sir.
But just like I said, Sarah, look like Sarah talk and say, nah, we not here, sir, because Sarah move up with me.
Astinil, I don't understand you. Astinil, what is happening, Astinil? All right. For the rest of you, I was watching my my direct messages, and I was responding to those direct messages. Yes, I'm proud of all of you. All of you who direct message me got the 2.196. And that's very good. Let me answer. Shamari, I don't hear from you. Hey, Shamari, hey, Shamari, where you going with? Man, I know
Well,
Shamari.
me see the message them coming, sir. So
Sir,
me even
go
bother
back
send
to have
my
us some little bit off.
No, hold on, hold on, utterly. You see, Shamari, you see what coming in?
me see them send the same answer when me get, sir. So me even bother.
No, me want to hear for no ramp in the eye, no. Want to see it, man. There now. I didn't see anything from it there now. I want to see it, man. Utterly, you're saying no?
Go back up to this third iteration for me. Get 2.22. Let me get that. Let me get 2.6. Let me do run. I'll check it over. Let me get off right this.
And incidentally, the topic finish here. All we have to do is just work questions and just get better at it. The topic finish.
Sir?
Exactly.
Oh, I got it there now. Yes. Yes, Mikey.
Sir, remember to post the last class recording because I was looking
Recorded.
for it.
Yeah, yeah.
I couldn't find it.
I took the device. I took the device with me and came back home with the device. Yeah, so that's true. It wasn't posted. So I'll do them tonight. Once it's coming, I'll just make one shot. Okay, Dana, got your message. I was going to say something else. So she there saying that she fall asleep, but she not come to class.
Sir?
Yes, please, sir.
Sir, when is mid semester?
Tomorrow.
Sir?
Tomorrow. Oh, gosh. Can't take them panic attack, sir.
This semester not just start you. This semester just start, you know. Well,
Yes, sir.
yeah.
But we got mid semester already.
No, hello. Your block scheduling for this course just started. You're in what? The second
Oh,
week of
oh yeah. Oh yes, sir. Yes, sir. For real.
yeah, yeah, man. We still have some time to go. If I give you a mid semester, it's just trapezoidal and this we can give for do. We have enough time to go, man. So she plan to stay on WhatsApp and instead of coming to class? Right. Utterly, I was kind of waiting on you still though, you know, to let me know if you're okay now. This is something here. All right, so let me go.
Yeah, man, sir, I'm good. I just sit off. Or may do back, may I recalculate everything but
All right. As I said before, this topic is also a must-have on the exam paper. So try and see if you can digest it. All right, so that's example 3. And I'm gonna post another example for you to do. Is every time you do one of these questions, you're supposed to get faster. You're supposed to get faster at it. A function is given by f of x equals to x squared minus 3x minus 5 with x equals 2 as your starting point. What is your first iteration?
2, sir.
Good. Use the Newton-Raphson method with 2 iterations to find an approximation to the positive root of the function. Give your answer correct to 2 decimal places, you see? So, Mikey, not Mikey, Chevy was asking, sir, how many decimal places? The question will tell you. The other one was 3. No, it's 2. On the mark, get set, go.
So, sir,
Yes, Papa.
when you see the x equal to like that, that is basically them saying x1 equal to.
Yes, 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 yes. And Shamari, it says with x equals to as your starting points, or starting points are normally the first iteration. Okay, remember you have to do the first one before you can do the second one, before you can do the third one.
Yes, sir.
So right, so that's what it is. All right, start for me, please. I will be disappointed to know that there are students who are just sitting and waiting back to see the results start working. Oliver, I'm not hearing from you.
I'm here.
No, ma'am. May I call you long time and you not respond to me either. So please start working, guys.
Sorry to interrupt you, but go back up, let me check. Go back up and it's up for the third exam. Get 2.6. All right. Yeah, yes, sir, I'm good. Can go back down and the focus. Okay, go down to the question you want me to work. Okay. Yeah.
Sir?
Yes, Papa.
Sir, I'm not sure if I do something wrong, All right, so the third iteration, I got an answer for that. And then I got a different one for the fourth, but the one for the fifth, it is the same as the one for the third. So I'm not
But why
sure.
which fifth iteration, though?
Oh, the second and the fourth is the same.
Why reach a fourth though? Because it says use use 2 as a first iteration, and with 2 iterations. Anybody else finish?
Yes, sir.
Okay.
So
What
I
did you
sent.
get? Oh,
Oh,
you sent it? What you
yes,
got?
sir.
Let's see,
For the
let's see.
second iteration, I got 2.6,
I got 2.6 for the second.
and for the third, I got 2.5.
Yeah, that's what I get.
2.5027, but I just leave it at 2.50. And then I attempted the fourth one, but I got back 2.50 with a bugger 0 behind it, so I just stopped there.
Okay. So I got the same thing. So for the second I got 2.6, and the third I got 2.50. So I should just stop there.
Yeah, man, I got them tell you if you do.
Okay.
Yeah, man. All right. So I was looking for the notification for the messages, but I wasn't seeing it, but I'm seeing the responses. You guys are seemingly getting the stuff, and I'm feeling so encouraged that I may have a repeat of a calculus 2 class I had about 2 years ago, 2022 in COVID, 22, 20, yeah, about 2 years ago, where all my students passed calculus 2. It's kind of look good. All right, I have an issue though, Chevy. Okay, so Taj kind of redeem himself a little there. I'm going to tell you. It says 2.5. Right. So the question says, not Mikey, Chevy, that you're supposed to use 2 decimal places, but you only send me 2.5. But sir, 2.5 and 2.50 are the same answer. Technically it is, but I did say 2 decimal places, so they're expecting me to put the 0 there. Yeah, Papa?
Okay.
Yeah, man. Because you give me the answer as 2.5 is just really 1 decimal place. So we have to follow the instructions to the T. So write your 2.50. I'm seeing everybody else writing the 2.50. Very good. It's very important. But sir, 2.5 and 2.50 are the same thing. Yeah. But what is not the same thing is one is 1 decimal place and one is 2. Right? So, all right. So what I did, and I crossed it out because I want to show you that they didn't ask you for it, is to look at the other iterations, just to show you what it is that we would have gotten. But the question did say they gave us a first one, and they said do 2 more. So if we get the first one, if the first one is given at x equal to x1 equal to, and to the 2 more, that means we can do x1, x3. So we expect to we expect to end our calculation at x3. Make sense?
Yes, sir.
Yes,
All
sir.
right. All right. Is there, I'm pausing 1 minute. Is there anybody in the class that is not understanding? Because me feel very excited now, I'm very encouraged.
Basically, once I set to 2 decimal place, right? If you put 2.5, you're right, 2.50.
Same way so.
All right.
All right. So this is now 8 o'clock. We have an hour. I have 2 more questions to give you. I have 2 more questions to give you. And then what I can ask you to do maybe is to look at the past paper so we can possibly work a question from the past paper, because it's always very important that we work some past paper questions. Find the solution of f of x is equal to x plus e raised to the x near x equals -1 to 3 decimal places. What is your x1 value?
-1.
-1, right?
Very
Okay.
good. So this one says to find the solution of that function near x equals -1 to 3 decimal places. How many iterations are we supposed to be doing here now?
So,
How many iterations are we supposed to be doing?
until,
I don't hear you.
until it equal the previous iteration.
Very good, son. Very, very good, son. Excellent. You hear what Chevy says?
Yes,
We're
sir.
doing that. We're going to do as many iterations until we get our consistent answer. So we're going to, if it means we're going to we do the 5th iteration, and then we do the 6th iteration, and then we'll get to 3 decimal places to be the same thing. That's the time we stop. So sometimes they tell you how many iterations to go to. Sometimes they don't tell you, but you know when to stop when it is that you have gotten your answer within the constraints. In this case, it's 3 decimal places. All right, on the mark, get set, go. Very good, guys. You're doing very well.
But sir, there's a
Yes,
problem.
Papa.
There's a problem for me, you know, sir.
What?
The first derivative of the equation here. You remember it, no, sir?
Therein lies your problem. Anybody can tell me what is the differential of e to the x?
I think it's itself.
Very good. So e to the x is e to the x. And then you're going to differentiate the numerator, the power, but the differential of the power in this case is 1. So it's going to be just e to the x. So what is going to be the differential? Give me the differential of the function now. F dash of x equals? Talk to me.
1 plus e.
Finish it, Shamari.
1 plus e to the x.
1 plus e to the x. All right. Good job. All right. Run it. But Chevy, big man thing, you see, so we have a problem if you don't know if you differentiate the function.
Yes, sir.
Yeah, man, you can't move at all. All right, then, cool. Hold on there, hold on there, hold on there. What on?
Still working, sir. Working.
Still working, sir.
Yeah,
Same here.
actually not hear nobody actually them short, and I sound like I'm gonna drop asleep. I still need reach class yet?
I,
Actually,
no,
she's
sir.
not gonna sleep, you know.
I think she said she don't watch the recording. And
Oh,
so, yeah.
okay.
Sleep, sir.
That means me could have go sleep then too. Oh, but you're not gonna recording if me go sleep. All right, got you.
I mean, I want to do full. Anybody get 0.5379 for them second? Come on, I want to do foolishness again. Anybody done the second one?
For the second one,
Negative 0.5379.
379, yeah. But
Sir,
on a
Sunday.
3, oh, go ahead.
Oh, me run off my one.
Same.
Oh, run it off.
So I'm negative 0.538.
Wait, yeah. Alright, cool.
Sir, you can check the chat, sir.
Alright.
All right, so I am liking the the efforts that you guys are putting into the work.
If I go through the step them sir, cause when we put in the e to the minus one on the calculator, it gave me error, so but I wonder why.
No, but it shouldn't. So it work for you now? The e to the minus one work for you? No? Shamari?
What was that, sir?
And I'm saying the e to the minus one work for you now? When you put in e to the minus one, that's what you get now. Because e to the minus one is just technically 1 over e, which would be
Syntax error. So the calculator must have 82 functions, and I wonder if that's why.
someone that's put in e to the minus one, that's what you get, please. Strange.
As me either work, because e to the minus one is the same thing as 1 over e, right? So
Yeah.
me me put in that, I'm
I'm
still
supposed to
get
get something like
error.
2.7181 or something like that.
Actually, I don't know, sir. May I get error?
All right. Can somebody put in e to the minus one, that's what you get, please?
It's like 0.367.
Hmm?
0.3678.
No, sir.
Oh, no. What is that wrong, sir?
So e to the minus one, sir.
Yeah.
Yes, sir, she correct.
I got 0.367.
At 0.367 I get again.
Yeah.
0.367. Oh, yeah.
Sir.
Yeah.
Yeah.
0.3679.
79.
Okay. Sorry. I was checking in my headspace because I put negative 0.6321. So I was subtracting 1 from that. But yeah, 0.3679. Because when I add that to this, I'm gonna get 1, which is this one that would have been added to it. Sorry, I was just doing some back calculation. What brand calculator you using, Chevy?
Casio.
Casio who? 82, 115.
Yeah, 82 MS.
All right, do me a favor.
Okay.
Look at the back side and see if you see a reset button on it for me, please. Yeah, no?
Well, sir, it I'm not me if it's a button now, but you can look at
There's a little hole and it's a reset, don't?
just now reset on it.
You know, see a reset. All right. Click on shift. Click on mode. Mode is to the top right hand.
Yeah.
What comes up?
Right. MCL mode all.
Click on all. All is 3 or
Yeah.
click on 3 and then equal. It says reset all now.
Yeah.
All right. Try e to the minus 1 now. If you don't get it, throw it in the bin.
Sir, me get in, sir.
So who said they never get it? Shamari, you know.
Shamari, yes, sir.
Chevy, where you make me do the exercise with you? If I know you're supposed to talk to Chevy. Sure. Shamari.
Me there do it same time, sir.
But which calculator you have, Shamari?
Same one as Chevy, sir. Casio FX 82 MS.
All right, the same thing. I'm gonna tell Chevy for do. You do it?
Yes, sir. Me do it. I'm still
All right,
get error.
You still like an error?
Yes, sir.
Wow.
Sir, same thing me I get to know, but I had to do it a different way. So what I would have done is put, we call it the -1 in a bracket first.
Oh yes,
press
that's what you're
enter.
supposed to do. That's what you're supposed to do.
And then press
Look,
Shift LN.
Thing there, exactly how I have it on the screen is how I want to put it in. Try that, Chevy. Try that, Shamari. E open bracket, -1 close bracket, and put it.
So it shows the right is using because they have the alpha.
Oh no, man, you're not supposed to be. No, film the 82 have alpha on it. The 82 don't have alpha on it.
Yes, sir. You have shift and alpha, you know.
You serious?
Yeah.
No, man, it's the one that says e to the x. Shamari is supposed to be using in the middle of the calculator. The one with over ln.
Yeah.
Right, that one they must use here, Chevy. I mean, Shamari.
No, sir. I just whenever I use that one, I get the error. But whenever I use the alpha with the E, I don't get the error.
No, man. Yeah, it's supposed to work both ways. Can you use the ln function for me, please? The e function that comes up on the calculator. Press the e function, and they get e to the x. Then open your parenthesis, press -1, close the parenthesis, and you should get the answer. Try that for me until you forget it.
Syntax error.
Hold on.
Hold on there, sir. Let me try something. So, oh. So, but two of them give me the same answer.
What same answer?
All right. The E. Oh, I use the E. I use the, I call that thing here. You know that greater hand sign but turn upside down. Yeah, I'll do the E with that sign and -1.
Okay. Right. So you're raising it to the -1, but all right. So let me ask a question. Look at the function that I have on. You know why? I'm spending time on this because
it worked
if you're going to the exam,
yeah,
you need to know how to input the data. Press the exponential function for me. It's not. Press the exponential function for me, please, and you're raising e to the -1. So either you're gonna press. Work with me. Let me give you some algorithms. I'm going to give you two ways. Press e to the x for me, please, on the calculator. Find the function e to the x.
Yeah.
Then you're going to look for x to the y or y to the x on the calculator. Are you seeing x to the y or y to the x?
Hold on. X to the Y. Where that is again?
Supposed to be somewhere in the top left-hand corner-ish, middle-ish of the calculator. If you're not seeing that, look for the upside down V. When you press the upside down V or the x to the y, or it could be y to the x, or the upside down V, then you're going to open your parentheses. You're going to put your -1, then you're going to close your parentheses. Press equal and tell me if you get the answer now.
Syntax error.
Let me see if you can find a calculator like that. Hold on.
But sir, when time I do the alpha and E, I get the 0.6321, -0.6321.
All right, here's the plan.
I'm not sure.
Turn on your video, Shamari, onto your calculator for me, please. I don't know if you're using a computer or your phone, but turn on a video and demonstrate what it is that you're doing, please? We have to get this. So we have to know if we're going to use the alpha or we're going to use the exponential function. Because you can go into the exam and it can give you different answers and you're going to mark it wrong.
Okay.
All right. Let me see the we're going. Let me see the point to the calculator. Let me see what is happening. All right, I'm trying to pin this thing here, but it's not. Okay, so it is pinned, but its name must be right now.
Then put in a bracket. No man, take out the sign, take out the sign. Yeah, let's put in the bracket. -1. So
Wait,
Alright.
another alpha, I'm supposed.
All right. Clear the calculator again for me, please. All right, good. All right, go to the exponential function for me. All right, the e to the x comes up. That's the e. That's an e.
yes, so the e to x1, that's it.
All right. Press the upside down v for me, please. Open the parenthesis. -1. Equal. All right. All right, go to hold on now. And that's and the e that you press that is above the ln function. Is it?
Yeah, man, I think that e then.
Yes, sir. Yes, sir.
But that's strange though. Put put e to the 1 for me, please. Evaluate e to the first power. You're also getting syntax error.
Yes, sir.
Something is wrong with the calculator.
Wait, sir. If him can, let me see here. Him can press 1 equal. Let me see first. 1 equal. Then do the shift ln. Press enter. R equal. I'm supposed to get, sir?
2.781.
Mm-hmm.
Yes. All right. So therefore that's the algorithm you have to use. Then press the -1 first.
Yeah, I have to do it that way because I'm the same calculator.
Press the -1 first. Then press shift and the e to the x. E to the x equal.
No, you have
And
to.
you get the syntax error. You have to put the -1 in parentheses, because you can't take the negative of a log number. So you have to put it in parentheses for me. Negative, open bracket, -1, close bracket, second function, e to the x. All right. I don't know. Hold on. Let me see if I can find a version of that calculator somewhere. Because anybody oh Lord. Hold on, I'm supposed to um uh, problem is I find a calculator, but it's not the 87, it's a 570 MS, but guess what now? That the battery did. Sit now, help me none at all. No, help me. But this is strange though. That one is very strange. All right. Let me think it through. Let me think it through. I think so today now. I think there's a negative sign that has to be in parentheses that is causing the issue, but let me think it through and let us just work another question in the interim. And let me think it through. Okay, we have to solve we have to figure it out. Go
Sure.
ahead.
I did it again without raising it to the power. I didn't get syntax error.
You did it without raising it to the power? I don't
Yes,
understand
sir.
that.
Without using up down. Well,
Okay. So
yeah.
you just put e to the negative
Negative
one,
one. Yes, sir.
and you got the answer.
Yes, sir.
Try that for me, please. Shamari.
Repeat that, sir. Just put E to the negative
Just
one.
E, open bracket, negative one, close bracket.
Syntax error.
And then shift ln. Shift ln negative one.
Kind of strange though.
I think he may need to share back his screen and let Tajay guide him.
Yeah, because Taj, you said you have the same calculator, Taj?
Yes, sir. That's the same calculator.
Share back your screen.
Share back your screen, Sheffield. I mean, Shamari, please. Is there anybody else that has a difficulty? We have to fix this, because I don't know if you're going to get an exponential function. And the exponential function can make or break.
Yes, sir. 10 mark this.
Yeah, man, 10 marks. That's too much marks for good.
Oh, one
All right.
second. Where is the screen? Oh, see, sir. Let's see if we can view. One second. Okay. Reset the calculator one time. See.
Right.
All right. Let me see here. Press Shift ln and negative one. Don't use that one there. Just yeah, normal negative one. That. No, not the one there. Not the negative sign there. Yeah. The negative one, yeah. 1. Enter. Are equal.
You get the answer now.
I believe at the negative 1 we might use up this one. I give him the
Yeah,
issue.
but
But is this they're saying that this is the same as e to the negative 1?
That's
No, you're breaking up, Shamari. Say it again.
I was saying that this is on the calculator right now looks like e minus 1. So they are saying that it's the same as e to the
No, that is
negative
e.
1.
Right. That's e to the negative 1. Yeah, that's e to the negative 1.
Because
But
the way
I'm wondering,
Go ahead,
though why that negative sign is not working though. All right. For whatever it is just now, we're not going to use that negative sign again here. We're going to use a regular negative sign on the bottom part of the something.
Mhm.
All right. Thanks. Taj.
Yeah, man. I was having the same issue, sir. So I took
Okay.
the day yesterday and just try to find out some ways to fix it.
Okay. I don't understand why though. Interesting. All right. Let's just run another question. Thanks again, guys. Let me just run another question. Okay, so we all agree that it's going to be negative 0.56.
3 decimal places.
Right, 7. All right, very good. Last one, and then all right. This one may utterly wake up.
No, not this time.
You're too quiet, man. All right. All right. Last one. Find the root of the equation of an equation. F of x is equal to x cubed minus x minus 1 using Newton-Raphson method. Note, you are not given the initial guess, so you'll be required to find it. Anybody knows how to find it? Matter of fact, don't answer. Don't answer. Don't answer. I'm going to give you 2 minutes to find x1, and I will come back to you in 2 minutes, starting now.
Sir, you're sharing something? Oh, okay.
Seen it?
Yes, sir, I seen it.
Example 7, I want you to do for me. I'm giving you 2 minutes to find x1, your initial guess, and then I'll come back to you to check on it. All right. Has anybody figured out X1? That's the one suggestion so far. Anybody figure out X1?
Sir, I think the midpoint is 1. Because I tried 0, the initial guess 0 and 1, and I got two negative,
Mm-hmm.
and then I tried 1 and 2, and I get a -1 and a 5. So it would be between 1 and 2. So the midpoint would be 1.
If it is, think about it, Mikey. If it is 1 and 2,
Yes.
if it is 1 and 2, what's the midpoint?
1 and 2
One.
will give it 1.5.
Yeah, 1.5.
It should be 1.5. Okay. Well, if that is the answer, it should be 1.5. So let us check it together. So if this is 0,
Yeah. Mm-hmm.
it's going to be equal to -1. So that goes to 0, that goes to 0, it's -1. So let us check. So we'll move from 0 and we're going to try 1. 1 cube is 1, minus 1 is 0,
minus 1.
minus 1. So it's going to be -1 again.
Mm-hmm.
So we're going to try 2. 2 cubes is 8, minus 2 is 6, minus 1 is 5, positive 5. So my value would lie between 1 and 2. See there? When it is 0, it is -1. When it is 1, it is also a -1. But when you jump up to 2, you get 5. So because there's a change of sign right here, so it means then that you would have crossed over your exact root. So it means that the range lies between 1 and 2. The questions that you get in the exam oftentimes come with examples like these, where you will have to first find the X1 value. Should you see that?
I remember the last part.
Yes, sir.
All
So
right.
you know what I did, sir?
Huh? Say it again, Chevy.
You know what I did?
What you did?
Use the -1 and 5 to find the midpoint of those truths.
Oh, no. I see, oh, you get the 2. You add this to this and divide it by 2.
Yeah.
No, it's a 1 and 2 you have to use, the X values.
Oh, the X values.
Yeah, it's the X values, not the FX value. So you can't make that mistake again. All right, got you. All right. Now run that question for me, please. Quick and fast. We have 10 minutes. Quick and fast. Finish it off for me, please. What's the answer?
Sir, for the
1.247.
Say it again.
1.34. No, 1.3247.
Okay.
Same, sir.
yes, same, sir. Mhm.
Excellent. 1.3247. Excellent. Excellent, guys.
I'm
That's
sorry?
where we're gonna end. Yes, Papa.
I think I do something wrong. Don't
Mm-hmm.
get that. You can go to the second one. Second
Sure.
item.
1.3478.
Sir, what if I don't show someone working out? I'll still get the full marks.
All right. So so if you go up to like the third, this one was how much?
Second round.
The fourth iteration. If you go to the fourth iteration, the question may be a 10 marker. You'll get 2 marks for each of the iterations, and we have to see the calculations. So I would say as best as possible, Chevy, don't skip none of the steps. If you do it in class, you get a shortcut to finish the question quickly, fine. But when I'm going to the exam, show every detail of the calculation, because for 10 marks, we're not going to, if I don't see it on paper, I can't assume that you have the answer. I can only credit you for what I'm seeing on paper. So show the detailed calculation for each iteration. What do I mean by detailed calculation? You're going to show the substitution for the f of x, like I did here to get the 0.1006. Then I'm going to show it for the differential, and I get that. If you don't want to show this piece, I mean, it won't kill you to show it, but I also need to see what the third iteration is. You must see, you do get marks awarded for your steps. So if I'm not seeing the steps, I can't award a mark. If the steps are not shown, I can't award a mark.
Sir,
You don't want to get the question right, but you only get 6 out of 10. Right here, so Mikey?
yes, sir. Mr. Wanna go around.
Okay.
Not differentiate properly.
Yeah, so if you don't, yeah, so you remember I was saying to Chevy earlier?
The 3 at 2 there for the second derivative.
Yeah, man, but remember when you differentiate it once, the same differential you have right here, so it's the same differential we use in here, so just make sure that the differential is yeah, it's correct.
Yes, sir. So what I had 2 x squared minus 1, where it should be 3.
Okay.
Yeah, so that threw me off.
All right, got you. All right. To be honest with you, you guys did very well tonight. We started a topic on Wednesday, and we finished the topic tonight. Very good. I will look to see what I'm going to start next and send to you guys, so that you guys can just remind me if you don't see by, class is Monday. All right, I'll see if I'm going to take a little rest off now. Hopefully by tomorrow I can just think through my headspace what I'm going to do, and I can send out a little message. If you don't see it, just drop something in the group and just remember so I can tell you. So you can read up about it, and you can, look at the recordings in the past about it, so forth and so on Edicosoft computing work, etc., etc. But you did well. Thanks for coming out. Thanks for the wake-up call, Shamari.
No problem, sir.
Yeah, man. Big up on yourself. All the best, yeah?
All right, sir. Thanks again.
Enjoy your weekend.
Okay, sir.
To you too. Thank you, yeah, man.